Welcome to Parallel Lines Cut by Transversals, the 9th video in the Pearson Geometry series. This is section 2.1. A line that crosses two other lines is called a transversal. That would be this one right here. When the two lines crossed are parallel, a number of interesting relationships occur. Corresponding angles are the angles that occur on the same side of the transversal, but inside and outside the lines. So this is an example of a pair of corresponding angles. With alternate exterior angles, exterior being the outside, alternate meaning both sides of the transversal, opposite sides of the transversal, outside the parallel lines. So here and here is an example of alternate exterior angles. With alternate interior angles, the angles fall on opposite sides of the transversal, but inside the parallel lines. So here and here. And with same side interior angles, they're on the same side of the transversal and inside the parallel line. So here and here. All right, if we take a look at these relationships, we find that we've got a couple of theorems here that we can use. So first of all, with our same side interior angles and same side interior are going to be right here and right here, or on the other side, we find that those angles are always going to be supplementary. So same side interior angles are supplementary. That means that they are always going to add up to 180 degrees. Okay, now with corresponding angles, okay, and corresponding angles are on the same side but inside and outside. So for instance, here and here, or we could do this one and this one, or this one and this one. A lot of different ways that we can do that. Those look congruent and those are congruent. And so corresponding angles are congruent. Okay, let's take a look at alternate interior angles. Alternate interior angles are going to be right here and right here. Opposite sides of the transversal, but inside the parallel lines. Alternate interior angles, also known as AIA, are congruent. And alternate exterior angles, so right here and right here, or right here and right here, are also congruent. So alternate exterior angles, also known as AEA, are congruent. All right, let's flip this to the other side because, as usual, we can use these to solve algebra problems. Okay, let's take a look at this first one. So we know that this angle is 64 degrees, and this angle is 4y plus 16 degrees, and we know that those are same side interior angles, then we know that these add up to 180 degrees. So we can set this up as 4y plus 16 plus 64 is equal to 180 degrees. If we combine like terms, subtract from 180 and then divide by 4, we're going to end up with a value of y is 25 degrees. Okay, let's take a look at problem number 2. Okay, so 5x plus 35 and angle 8 are corresponding angles. That means they're congruent, but we don't know what angle 8 is. But we do know what this angle right here is. And these are going to be a linear pair, which means they're supplementary. So if we subtract 45 from 180, we're going to get angle 8 equal to 135 degrees. So that means that 5x plus 35 is equal to 135 degrees. So 5x plus 35 degrees is equal to 135 degrees. We subtract 35 from both sides, divide by 5, and we end up with x is equal to 20. And the last one, probably the easiest one. These are alternate interior angles. They look congruent and they are congruent. So we can say 3x equals 120 degrees, divide both sides by 3, and x is equal to 40. The proof is a little bit more than we want to go into right here. So we're going to wait and do this in class together. Catch you later.